derivative exists and n plus 1. Nth derivative is continuous. Okay. So here it's like number one condition. It's the extension of the mean value theorem. So the nth derivative exists. Yeah. So continuous. In the interval and n plus 1 derivative exists in the interval I. And in Taylor's formula, remainder term is this one. Okay. So at any point in the interval, we can get this within the interval. Okay. We can have this series expansion of, this is known as the Taylor series expansion. Okay. For fx equals to f of a plus x minus a, f dash a, and here 1 factorial. Okay. In the numerator, we have the factorials. Okay. And here x minus a square, it keeps on increasing, and the derivative. Okay, first we have f, then the derivatives at the point a. Remainder term is the n plus 1 term. Okay, the c is at point in a and x. Okay, this is the known as the remainder term or the error term of the expansion. We have done this one. Okay, so now Taylor series, the same thing. Okay, in the Taylor series, we say this n approaches to infinity. That means our function is infinite times differentiable in the this one. Okay, if n approaches to infinity, what you understand? Okay, the functions like sin x, it's infinite times differentiable, exponential, cos x, okay, log x, okay. Log x, for the log x, we have to look at the interval, right? We will go for the non-zero positive intervals. Okay, so here then our f of x. So normally we will find the Taylor series of a function. Okay, looking at what is the condition. Okay, so this is your Taylor series. The terms, okay, since the remainder is approaching to 0, okay, this is known as the Taylor series. Okay, and this one, the Taylor series expansion of f of x at the point a. Okay, and this is called Taylor series. When, okay, Taylor series. Now when a equals to 0, when a equals to 0, Taylor series will reduce to Maclaurin series, or Maclaurin series is a special case of Taylor series. So we obtain Maclaurin's series. Okay, this a is 0. So what happens to the series? You can see f of x. Okay, let's see. So f of 0 at 0 plus x minus 0 is x by 1 factorial. We have f dash 0 plus x minus a square. So x minus 0 square will be x square. Then here the second order derivative. Then here we have third order derivative. Okay. And the nth term, n plus 1th term, since we have f of 0 here, will look like this one, x power n by n factorial, and the nth derivative of f at 0. Okay, so it's an infinite series. Okay, since we look at the functions with infinitely differentiable. Okay, so this one is the Maclaurin series. Okay. Okay. Okay, so let's do some examples. Okay, I think we have done for the sin x, right? So let's do for a particular. We have done it for. Let's do it for 1 by x. Find the Taylor series expansion or f of x equals to 1 by x at x equals to 1. Okay. So you will consider an interval, okay, like 1. So you will consider an interval around 1, and we will make sure that x non-zero. So you can consider the interval as zero point 0.5 to 1.5, okay, or it can be zero point 0.9 to 1.01. Okay, this is how you can consider your interval. So here, see, okay, let me do this one. Okay, so here for f of x equals to 1 by x. So the values of the function, okay, let's try the derivative. We will look at this as f of x equals to 1 by x. So f dash x will be minus 1 by x square. Now f double dash x equals to 2 by x cube. Okay. Then triple dash x is 3 into 2 divided by x power 4. Okay. So the similarly we can try here. So what happens here? F of 1 will be 1. F dash 1 will be minus 1. F double dash at 1, the value will be 2. F triple dash at 1 will be 6.
Ma'am, it will be minus 6 no, because that minus 3
Ye-
we are multiplying.
yes. It's minus 6. Thank you. Okay. Then we have, if you go per, you see F fourth derivative. So it will be 4.3.2 by x power 5. Okay. So f of fourth derivative at 1 will be 4 factorial. Okay. So here you can write minus 3 factorial. Okay. So if you want, you can also write the nth derivative of f at 1 is minus 1 power n. Okay. Minus 1 power n into n factorial we are getting. Here 1 factorial the say derivative. So it is n factorial. Okay. For all n greater than equals to 0. Now we will look at the Taylor series. Okay. So Taylor series of 1 by x at 1 is f of
1
1
minus
plus
ma'am x minus 1 whole square ma'am x
sorry,
minus 1 whole
sorry,
square
you're
x
right.
minus 1.
Yes. I'm so sorry. I have written x minus 1 square, x minus 1 cube, x minus, and it goes on. You can substitute the values now.
So every time that when n tends to infinite, Rn मतलब Rn term tends to 0.
Yes, you can show this one. In the Taylor's formula, okay? In the Taylor's formula. And here normally you will have some error. But whenever you find Taylor series, see what when you're saying n approaches to infinity, the important thing is here this fn. Okay, the nth derivative we have the function is infinite times differentiable. Got it? And here you see, when I am seeing in the Taylor's theorem, it's nth and n plus 1. It's like fourth order derivative or fifth order derivative. It's like that. Suppose you go for x power 5 and you have the interval like minus 1 to 1 or minus 0.5 to 5. So at least you can say up to fifth order derivative it exists. Fourth order derivative it is continuous. Got it? Fifth order derivative it's continuous. Sixth order derivative exists. That way. Got it? So that time you will be getting up to sixth order. Okay, we will do that also. What I mean. But if you are finding the Taylor series, this is what you have to write. Okay. And you have to this okay, there is one thing. This error term is known as the Lagrange's form. There are many forms of error term. So this one is Lagrange's form of remainder. Of remainder. Okay. So this is one form of remainder, and it's this is also known as the error. Okay. When n approaches to infinity, this error term must go to 0. Okay. So it will be very small. Okay. So here this one. Okay. Now we will substitute. What is the value of f of 1? This is 1.
1. 1 minus x minus 1.
Should I write minus 1, or to make it a form I will write
Minus 1. Minus 1.
I will write minus 1. Okay. Got it? No problem. No issues. This is minus 1. Then x minus 1 square is minus 1 square and 2 factorial, because I will try to write it in a series form. That's why I'm writing. Okay. Cube minus 1 cube 3 factorial. It's a very easy function, so we can write.
Ma'am,
But
by 2
Ma'am,
factorial,
by
by
2
3
cancel
Bus
అయిపోయింది.
factorial.
factorials.
By 3 factorial. Yes,
yes,
ma'am.
yes,
Yes,
yes.
ma'am.
Thank you. Whatever. Okay, whenever I'm doing any mistake, okay, I'm leaving, you just remind me. Okay, so x minus 1 power 4 minus 1 power 4 and here 4 factorial divided by 4 factorial. Okay, so now you can see what is the situation. These things will get cancelled out. Okay, and we are left with only
Ma'am,
one.
ma'am, minus 1 whole square minus 1 whole cube, that's not required, no, ma'am.
We will actually, I will try to write it in a series form. Okay, annotation. Got it? So that's why I'm writing it. So we are getting a series of this form. Okay. So let me show you why I am writing this. Okay. It's okay if you don't write, that is also okay. Okay. See, we can write it in a series form. Minus 1 power, if we write the nth term also. So the nth term will be minus 1 power n minus 1 power n. This is n plus 1 term. So now will be summation n equals to, see, this will be minus 1 power n, this will be x minus 1 power n. So n will start from 0, then this will be 1, 0 to infinity. So this is your series. And
Ma'am,
this,
if they ask series, we have to write n term also, ma'am.
no, it's okay. If you don't try, if you can
If,
write it, it's good.
if you
Okay. Like,
differentiate 3 terms, that's enough, ma'am.
3-4 times only. Okay.
So, ma'am, it is
Okay,
not
ma'am.
mandatory to express it in that summation form, right?
No, but it's easier. See, if you look at this summation form, it's easy to look at the
Yes, ma'am.
characteristics of the function. If you look at it, like each term, it's a alternating series. Plus 1 minus 1, plus sign minus sign will be there. Then there will be the power of x minus 1 square. So it's better. Okay, if you can, but it's not mandatory, right? You can leave here also, right? Here without putting plus and minus 1, simply the Taylor series. Okay, got it? So,
Yes,
and
ma'am.
you have to make sure we are expanding this Taylor series, okay, at 1. Okay, since we go for very small intervals, so it's better if you go for 0.9 to 1.1. This way you can go. Anything you can say. Always you try to consider the small intervals. Okay. Or you can also go for zero point 0.5 to 1.5. So don't go for 0 because 0 it's not defined the function. What it? If you put it 0, so don't include 0 in your interval. Okay. So if you don't write also it's good. Normally the interval will be from a minus h to a plus h form. H is a very small interval. When we are going expanding f of x in Taylor series at x equals to a, normally we consider the interval like this. Got it? Where h is a very small positive integer. Okay. So here it's a very well defined. If you are expanding around 1, it's a well defined function. Okay. So now we will look at the uh, Maclaurin series. Okay. We have done the, if you remember, the expansion for the sin x. Okay. Now we will do it for
Ma'am.
the Maclaurin series. Okay. That means at 0. So find the Maclaurin series for fx equals to sin x. So Maclaurin series means it's a special case of Taylor series where we are finding.
X equal to 0.
About 0.
Okay, so
0.
about 0. So we will find out derivative. As I said, you also know it's infinite times differentiable. Okay, let me do this one. Okay, so here, so I'm writing one. Okay, then you can do fx sin x. Okay, let's write this way. Then it's easier. Cos x. And if you go for the second order derivative, it will be minus sin x. So if you go for the third order derivative, it will be minus cos x. Then if you go for the fourth order derivative, it will be sin x. Then corresponding values, okay, up to at least try up to 3. 4 if it is easier, go for the fourth order derivative. Okay. 0. F of 1 will be f dashed at 0 is 1. Then if double dashed at 0 will be 0. Then if triple dashed at 0 will be minus 1. And the fourth order derivative at 0 will be 0. Okay, so only the odd order derivative exists and others are 0. Okay. So now if you, and after that if you go for it repeats itself. Like fifth order derivative will be again cos x. Got it? Sin x. See, fourth order actually we are getting the repetition. Sin x. Then fifth order will be same. Sixth order will be same. Okay. So for this particular case, okay, the derivatives repeat in fourth cycle. Okay. 0, 1, 2, 3. Then on the fourth one, sin is repeated. Fifth will be cos. Sixth will be minus sin x. And the seventh will be minus cos x. Okay. So, okay, you can write here also the derivative repeat in fourth cycle. So we can write the Maclaurin series. So f of 0 plus f dash 0 Okay, now we will substitute the values. F of 0
0 plus x.
is 0. So 0 plus this f dash 0 is 1. So this is x. Then we have
0.
0
0.
0.
Minus x cube
Then
Plus
minus
x.
x cube by
Minus
3
x cube by 3.
factorial.
upon 3 factorial
factorial. Then again 0.
plus x 5. Yes.
5 factorial. See, we are getting the series of sign here. Maybe it's 0. So you said in last time, so at 0 we are getting this is x minus x cubed by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial. Okay. So if you want the regular series, we can write it's the alternating series minus 1 power. So this will be n. Okay. So here this and we divide it by 2n plus 1
Factorial.
factorial and here x power 2n plus 1. And n is from 0 to infinity. Okay. So this is the, you can see this is the regular series of sine. Okay. For all x, this is the series for sine x. Okay. So now you have the idea for Taylor series and Maclaurin series. Okay, so I'm giving you a few questions you will write. Okay. Okay, so you find the Maclaurin series. Okay, and you will do it. Whoever I will ask the person. I mean, you have to do this question, and I will ask someone. They will he or she will explain, and I will write down. Okay, got it? Because you cannot write. If you have, do you have any of you have board? Then you can write. Are you getting? I will write down the question, you will solve it, and I will ask randomly to one of you, and he or she will explain it to me. I will write down the answer. Got it? So you find the Maclaurin series. Find Maclaurin series. One upon one minus sin x. Okay. So it's a easier one. So you will solve this one, and randomly I will ask one of you, and whoever I will ask, he or she will explain it to me, and I will write it. Okay. So start solving. Try to rise up to 5 terms. Okay, let me write here.
Ma'am, at which point?
Maclaurin
Zero.
series.
Zero.
At which point?
Sorry, ma'am. Sorry, sorry.
To 5 terms. See, you are asking some of you in the last class the Taylor series. Is it clear now? Some of you said only 63. Where are other 7? I have to take the attendance also. Okay, at the end I will take. But who was asking? Last class you're asking? No, I don't know now. Is it clear how to find Taylor series? Reddy, is that you? You were asking me? Pritham Reddy, are you there? See, if you don't respond, I'm not going to give you attendance also. Ravi Kumar.
I'm done.
Okay, you explain it to me how you're doing.
First of all, differentiate f of x.
F of x. First fx is 1 upon 1 minus sin x. Okay. So here, then we will find f dash x. How much is this?
Cos x by 1 minus sin x.
Okay. Then the second order derivative.
It is again coming 1 by 1
Plus
minus sin x.
sin.
Ma'am, in f dash x here, there should be 1 minus sin x ka whole square.
Yes, ma'am. Whole square.
1 minus sin
Denominator.
x whole square.
Whole square. Okay.
No, ma'am, in f dash x.
F
Ma'am,
dash
in
x, ma'am.
first
In F dash
derivative.
x.
First derivative.
f dash x में होगा मैम.
F dash x
Okay.
equal to 1
And
minus sin
here,
square.
and the
That's wrong.
1 minus sin square x
1 minus sin x whole square.
or 1
Sin
minus
x
sin
whole
x.
square.
Sin x whole square. Whole
Is
square.
it right?
It's wrong, ma'am. That's
Is it right what I have written?
F dash x right, ma'am. F double dash x wrong.
F
Now
double
you tell
dash
me
is wrong,
f,
ma'am.
f double dash x is how much?
1 minus sin x.
Wait. It's not responding. So how much is the second order derivative?
1 minus sin x whole square.
1 minus in the denominator,
Numerator, ma'am.
in the numerator 1 minus
2
sin
plus
x whole
sin
square.
2 plus sin x by 1 minus
Minus
sin
sin
x.
x
Here minus sin x.
plus
See, 5 terms I have written plus
2 cos square x
2 cos square x.
into 1 minus sin 1 minus sin
This
x.
much in the numerator.
No, ma'am. 2 cos square x into 2 cos square x into 1 minus sin x
This was
divided by 1 minus sin x whole power 4.
मैम जो माइनस sin x को ब्रैकेट के अंदर रख देंगे नहीं तो कंफ्यूजन हो जाएगा.
हाँ ब्रैकेट में लग f double dash x equal to 0.
okay. If you do the bracket, what happens? 1 minus sin
That's
x.
You can take 1 minus sin x as common.
no,
And
ma'am.
we are
Just
left with
simplify
1
0.
minus sin x.
Ma'am, just kept 0, ma'am. Then simple. Just take 0.
This one.
Sin x.
Wait. My OneNote is gone. Just wait. Okay, now you can see. So what is the second order derivative? Should I keep it like that if you are getting third order 0? Third order derivative is 0.
Ma'am, you can take cos square x
Yes, ma'am.
equal to 1 minus sin square x, and then it will be equal to 1 plus sin x into 1 minus sin x, and you can take common 1 minus
Ma'am,
sin x
then
whole
f
power
dash,
square.
2 plus cos square x divided by
lastly
1
f
minus
double dash x equal to 1 by 1 minus sin x whole square వస్తుంది.
So finally, how much you are getting?
Ma'am, 2 plus
1
cos
by
x by 1 minus sin x to the power square.
Ma'am,
Yeah,
2 plus sin x by 1 minus sin
2 plus sin x
By 1 minus sin x to the
by
power
1 minus
whole
sin
square.
x whole to the power square.
this much. Okay, now what is the third order derivative?
It is coming as cos x whole,
Cos x
whole 5 minus 2 sin x.
here in the numerator. Cos x, yes, you tell me. Cos x.
Yes, ma'am. Cos x whole 5 minus 2 sin x.
This is what you are saying.
Yes, ma'am. By 1 minus sin x whole cube.
Whole cube. And whether one more term we need, I think, since we are looking for 5 terms.
Ma'am,
How
you
much is
asked for
this?
5 terms.
So we will be getting 5 terms. 1, 2, 3, 4, 5. Fourth order derivative also we need, I think.
Yes, ma'am.
1, 2, 1, 2, 3, 4, 5. So what is the fourth order derivative? Is it a little complicated? Any of you done the fourth order derivative?
No, ma'am.
Okay, let's try for the fourth term. So what is f of 0? How much is it? 1.
Yes, ma'am. 1.
square.
And f dash at 0.
1.
1. 1.
And double dash at
2.
2.
2.
2.
Then the third order.
5. 5.
No one done for the fourth one.
No,
Okay.
ma'am.
But you see, I have asked you up to 5 terms. You have to do it. Okay. Okay, let's write the Maclaurin series. Okay. So f of x will be f of 0 plus x f dash 0
X by 1 factor.
plus x squared by 2 factorial plus x cubed by 3 factorial fourth order derivative. Okay. So here 1 plus 2x. What did you find f dash is?
1
1
plus
ma'am.
x.
So it is x
1 plus x.
Plus x
plus
square.
x square
Plus x square.
Plus x
plus
5x cube by 6.
5x cube
Plus
by 3
5x cube by
factorial.
6.
then this one you have not found. Okay. This is what you are getting.
5x square by.
This is your term.
Yes, ma'am.
All of you are getting this much.
Yes.
Any other answers? See, there is one more way you can write. Okay, it will be easier. Okay, so we are finding the Maclaurin series, and you know the Maclaurin series of sin x. That you can use here. Okay, that way you don't have to use. You got it? Are you getting what I'm saying?
Yes.
Ma'am,
Let
once
me
again.
see. You know the Maclaurin series expansion of sin x. Okay, see. It is f of x here. We have 1 by 1 minus sin x. Okay. And if you have, it is, what is the form? 1 by 1 minus omega kind of form. Right? You know, no? And what is the expansion? You already know. 1 by 1 minus p. And here, Got it? 1 minus sine x. This is less than. We need only the sine x value. Why I write minus 1x. Less than 1. Now you know the x series expansion of this one. You can use this one, okay? And this is for omega less than 1. So what will be the series? It's a geometric series. Got it? Or you can write it here, omega power n. Okay. You know this one? You remember this one?
Yes, ma'am. In complex numbers. In complex numbers, we
Binomial
will
Yes,
say.
ma'am.
series. Why? It's the binomial series. You remember for less than 1?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay. So here you see what you have to do this one. 1 by 1 minus sine x also satisfies this one. So it will be simply sine x or n n equals to 0 to infinity. Okay. No, because you what you are doing that is also right, but this way also you can proceed. You got it, but it's also a little bit. But since you already know the expansors, so it will be much easier. Like you have to only do the addition subtractions. Got it? You don't have to deal with the derivative. 5 terms you have to find. You have to write down the series for sine x also, and you look at that also. So here you see 1, and what is the series for sine x? Okay, so that is one of the form. Okay, this way you can also do, but you have to do fourth term. Okay, the series will be same in whichever way. First we have 1 plus sine
Got the
x.
fourth term.
But here also you have to do, but only the addition subtraction. Okay, 1 plus sine x, sine square x, cube x, 4x. Got it? Now for sine x we have x minus x cube by 3 or 3 factorial plus x power 5 by
3
5
factorial.
factorial.
3 factorial.
Okay, so this is one. Then the next term it's a sine square x. Okay, so only you have to look at the first few terms. Got it? Here, the only thing you don't have to deal with the derivatives. Okay, otherwise here also you have to look. This is one of the way, and sometimes it's easier. So I'm telling you, this is one of the way you can try, and many times it's easier also. Suppose exponential is there, that is much easier. This is cube, then x minus x cube by 3 factorial. Okay, so now you see first term will be 1, the next term will be x, and if you go for the square, second term square cube, so the next term will be x. Now you look at the next term, you have x cube by 3 factorial.
X
If you
squared.
go do it here, you are getting x square. So x square, see, same will come x square here also and here also. The third term will be x square. Now we will look at the fourth term. We have x cube by 3 factorial, and here you will have x square, right? Since you are squaring x square, then
To
this
the
square will be a bigger one. Okay, and if you multiply, that is that 2x p form, that
Coefficient
is
of
also
x raised to
bigger
4
one.
will be 1
So we
only,
don't.
ma'am.
And here you have x cube. You got it. 1x cube here you will be getting, and here it's 4. I'm sorry. X cube will come from here. Okay, so what will be the fourth term? Here x cube, here minus 1 by 3 factorial, 1 minus 1 by 6.
5 by
So 1
6.
minus
5
1
by
by
6.
6 is 5 by
5 by 6 x cube.
x cube. So here it is minus, it is plus. So whether it is plus or minus. See, here also
Plus.
it is plus coming. Then the fourth term. Four terms are there. Only we will look at the fifth term. Okay. So here it is x5 we are getting, and here it is x square. And if you look at one term, that multiplication, then we will be having 2 by 3 factorial x power 4. Okay. So here we are getting 2 by 3 factorial x power 4, and 1 x power 4
Minus,
will
minus,
Plus 2 by 3 x to the
minus 2x by 2x power 4 by 3 factorial.
and here 1x power 4. See, first term. Got it?
2 by 3 x power 4.
So
Plus 2 by 3 to the power 4.
plus 2 by 3 x power 4. 1 minus what you are getting. So 2 by 3 x power 4. Only the first term we are looking at. Okay. So we have 5 terms of the Maclaurin series. Okay. So this is one of the process. It's the same thing. You see, in whichever way you proceed, since we are getting the exact answers, our series will be same. That you remember. Okay. Whenever only we go for the approximations, that time you may have differences little. Otherwise, when we get exact, like first 5 terms are exact. So in whichever way, whether you proceed in this way or this way, you should have the same thing. So here only addition and subtraction is there. So this is one of the way you can proceed. Okay. Any doubt with this one? Okay. Okay, then you do one more. We will find the value of verify Taylor's theorem. We done this one. Verify Taylor's theorem. For f of x equals to 1 minus x pi by 2. With Lagrange's form of remainder. Lagrange's form of remainder means the usual remainder I told you. I've only told you one remainder, and that is Lagrange's form of remainder up to 2 terms in the interval 0, 1. So you only look for 2 terms in the Taylor series. Up to 2 terms in the interval 0, 1. Interval 0, 1. So what you have to do? So you have 2 terms, and the third term onwards you will consider the remainder. Okay. So here f of x equals to
Man, Taylor's theorem about which point?
0, 1, any point you can consider. You can consider 0 also. Consider 0, that will be easier, or you consider 1. I didn't give you the point, so in between 0 and 1, it's a closed interval I have given, so you are free to consider. At 0, you try. Okay, so try at 0. So f of x will be 2 terms. You will consider f of 0 plus x into f dash 0, and the next term will be x square by 2 factorial, and here this one will be c, and this c is in okay. So this is what we do. Now you find out f dash x. So what is f
Minus
dash
5,
x?
minus 5 by 2,
Minus
5 by 2,
5 by 2.
minus 5 by 2.
1 minus whole power 3 by x whole power
minus
3 by
5 by
2. 1 minus x whole power 3 by 2.
3 by 2. This is what I have written. Then the second order derivative,
15 by 2
because we need in the
15
remainder term.
15 by
Okay.
4 4
1 minus x power 1
15
by
by
2.
4, sir.
15 by 4,
15 by 4.
1 minus x,
1 minus x to the power 1 by 2. 1 by 2.
1 by 2. Okay. So now we will find
Yes,
it
ma'am.
at 0. F dash 0. If you have f dash 0, where our two terms are complete. So the value of f dash 0 is minus 5 by 2.
yes ma'am.
Because we should have the value at f of 0.
Minus 5 by 2.
F of 0 is 1.
1.
F of 0 is 1. Okay. Then f dash 0, what you said? 5 by 2. Minus 5 by 2.
Minus
Minus 5 by 2.
This is
Minus
1.
5 by 2.
And
15 by 4.
so what we
15
do
by
here,
2.
uh, yes, but we don't put x equals to 0 in the remainder term. Okay. This x is C is lying between 0 to 1. You can consider 1 also. Or anything, any term you can consider between 0 to 5. So let's consider any form we can consider 3 by 5. Let's say. So what will be the value here if you 3 by 5? Let's see, half is there. Okay, we will try to put square since we are free to choose here any value between let's make it 9 by 25. Okay, so it will be 25 minus 9, 16 by 24, 25, and the half will make it
4 by 5.
4 by 5. Okay,
3 ma'am. 3 total.
just you are free to choose this one. Okay, so it will be 3. Okay. Okay, so C we are choosing 9 by 25 just only for the sake of calculation. Okay, you can consider it 1 by 2. Anything you can consider. Got it? So this is 9 by 25. So we are getting a double dashed as 3. So let me write this one only for the sake of calculation. Okay, you are free to choose. Calculation will be easier, so we will consider this one. Okay. So now f of x equals to f of 0, that is, then here 3x plus 3x square by 2. Okay, 3x square by 2. So this is our remainder term, Lagrange's form of remainder. Okay, so nothing else, only this much you have to do. Okay, 3x square by 2. You got it? So write down one more question. If you have time, you do. So for every x, so you remind me to record the class. Okay, I didn't record today. So 1 plus x square by 2 factorial plus okay. Try it. Okay, like the previous one you try.
By using Maclaurin's series, we can prove. No?
Try use Maclaurin series. And you have exponential. It's given. The clue is exponential function. At 0 and 1 you try.
मैम इक्वेशन फिर से रीचेक कर दीजिए आप, मे भी कुछ गलती हुई।
यस मैम, दोनों साइड सेम ही है।
Left and
Same.
Yes, ma'am.
No,
बोथ
no, no.
साइड से सेम है।
Yeah. Sorry. This is e power x. You can write down this and check yourself also. Okay, we have very less time. Okay, I will give minutes. Roll 1,
Present, ma'am.
2,
Present, ma'am.
3, 3,
Government has released the list.
4,
Present, ma'am.
5,
present, ma'am.
6,
Present, ma'am.
7, 8, 9, 10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13, 14,
Present, ma'am.
15,
Present, ma'am.
16,
Present, ma'am. Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.